All right, welcome to Chapter 5 on Systems of Two Linear Equations and Two Variables. This is Section 5.4 on Applications with Systems of Equations. So there are many types of application problems associated with this systems of equations, and we're going to look at mainly the value and interest problems, mixture problems, and uniform motion problems. So, interest is equal to principal times rate times time. If you have some amount and you take it times its value, you're going to get a total value. For concentration, you're going to have some amount times the concentration. That's going to give you a total amount. And uniform motion, that's just distance equals rate times time. So with those main concepts there, let's go ahead and get started on some problems. So here it says, there were 429 people at a play. Admission was $1 each for adults and 75 cents each for children. The receipts were $372.50. How many children and how many adults attended? All right, so that last sentence is usually what we're going to set up for our variables. So I'm going to say, well, let's let X equal the adult tickets. So the number of adult tickets. And so then we'll say Y then is equal to the number of child tickets. Now, adult tickets were how much? They were $1 each, and these were 75 cents each. And I'm putting them in the same unit, so $1 and $0.75, okay? So can we write any equations? What do we know? Well, the number of tickets sold total was 429. And if there were X number of adults, Y number of child, we could say X plus Y is 429. Now, what we could do is we can say, okay, well, we also know a price. We know that's how much total was. Well, if we take this amount times how many there were, plus this amount times how many of those there were, that should equal our total we retrieved from sales. So that would be 1 times X plus 0.75 times Y, and that's going to be equal to 372.50. All right. Now what do we want to do? Well, now we have two equations, two unknowns. Now we have a system of equations. So now we have to solve it. Now we have to decide what is the best way to solve it. Well, that's up to each individual person. But I'm thinking we have an x and an x. So if I take and get one of these to be a negative, then negative one, not negative, negative, then that will be probably the easiest thing I can do. So that gives me then x plus y equals 429. Now notice I have 0.50, so I should probably put 0.00 so I make sure to line up the decimals. Now this is going to give me minus x. This is going to give me minus 0.75y, and that's going to be minus 372.50. All right, so x minus x is 0. 1 minus 0.75 is 0.25y. And here now I've got to do some borrowing. So that's going to be an 8. So that's going to be a 0, a 5, and that's a point. 8 minus 2 is 6. And now we got to borrow again. And 7 and 12, that's 56.50. Okay. Now I have to divide by 0.25. And if I divide by 0.25, what is that same thing as? Well, it's the same thing as multiplying by 4. So I can take 56.50 times 4, and I get 0. 5 times 4 is 20. Carry that. 4 times 6 is 24, 25, 26. And that's 22. And move decimal 2 places. And so it looks like y is equal to, oh, these are numbers, not dollars here, so better not put that. 226 child tickets. Okay, well, I can plug that value back up in here, and then I can solve for x. So then I can say, okay, well, now I have x plus 226 equals 429. We'll subtract 226. X is equal to, well, now I take that, that's a 3, that's a 0, that's a 2. So 203 adult tickets. Okay. So those are my two values, 226 child, 203 adult. Now what we have to do is we have to check. Does 226 plus 203 equal 429? So that's the first one. 226 plus 203 equal 429. Well, that's going to be 2 and 2 is 4, 2 and 9. So that's 429 equals 429. So that one checks. And now I have to plug it into this equation. So I'll have 1 times 203 plus 0.75 times, and that's going to be 226. And that's supposed to equal 372.50. All right, so 0.75 is the same thing as 3/4. So I'm going to actually have to take 3/4 times 226. Well, 2 will go in here 2, 2 will go in here 1, 1, 3. And so then what I have is if I multiply 3 times that, that's going to be 339 divided by 2. And so that's going to be 2, 3, 3, 9 over 2. And so that's going to be a 1, and then we're going to have 2, 1, bring down a 3, that's going to be a 6, that's 12, 1, 9, that's going to be a 9, that's going to give us 18, and that's a 1, bring down a 0, and that's going to give us a 5. Okay, so what we now have is 203 plus 169.50. Well, that's 0.00. And so that's going to be a 0.50. So that's 9, 10, 11, 12. Carry 1. That's a 7. That's a 3. 372 is what I have on the left. That equals the right. And so that is the number of child tickets and the number of adult tickets. Okay, so key things, set your variables first, and usually those are the things at the end of the sentence. Then set up your two equations, and then after that, basically solve your equations using elimination or substitution. Okay, what about this one? So we have a total of $50,000 is invested. Part of it is at 5% and the rest at 7.5%. The total interest after 1 year is $3,250. How much was invested at each rate? All right, well, let's say X equals amount at, let's say 5%, and Y is equal to the amount at 7.5%. Okay, so that's the amounts we're going to have for each one of those. Now, what are our equations? Well, we know the total is invested. So if we take X plus Y, that should be equal to 50,000. Okay. And then if we take each percent times that value and then add both of those together, we should get a total of that much interest. Now remember, when we're working with percentages, we have to convert to decimal. So it's going to be 0.05 times X plus 0.075 times Y, and that's going to equal 3250. Okay. All right, now what do we want to do? Well, let's see here. This one might be just as easy to do elimination as it is to do substitution. I'm not sure what I would want to do. Maybe let's go ahead and do substitution. And let's say maybe X is equal to 50,000 minus Y, because I just subtracted Y from both sides. Then I can plug this all the way back over here. And now I have 0.05 times 50,000 minus Y plus 0.075 Y, and that equals 3250. All right, so now I'm going to have to distribute. And so 0.05 times 50,000. So we have 50,000 times 0.05. So that's 0, 0, 0, 0, 1, 2, 3, 4, and then 25. Move it over twice. So that's 2,500. and then minus 0.05y plus 0.075y equals 3250. All right, so I've got like terms here, so I can add those. So let's subtract 2500 from both sides. Okay. Well, if I subtract off a 0.05 here, that's going to give me a 0.025y equals. And over here, that's going to be a 0, 5 is going to be 5, 2. We're going to have to borrow here. That's going to be a 2 there, and that's a 12, so it's a 750. And divided by 0.025. And so now what we have to do is, to get this to be correct, we have to move it over 1, 2, 3 decimals. So I have to go 1, 2, 3 decimals. So now we're going to take 75, then 1, 2, 3, 4, 1, 2, 3, 4, divided by 25. So that's going to be 3, 1, 2, and let's see, 3. Let's just do it so we have it in order. So then that's 0. Bring down a 0. That's that 0. Then that 0. And so it looks like we have y is equal to $30,000 in the 0.075. Well, if that's the case, x has to be $20,000 because the total was $50,000. So 50 minus 30 is 20. And so $30,000 at 7.5% and 20,000 at the 5%. Okay. So does x plus y equal 50? Well, yeah, we can add those two together and we get 50,000. So the first one checks. Now we have to take that times this and then that times that. So we'll take 0.05 times 20,000, 0, 0, 0, 0, 10, and then move the decimal 2, so it's 1,000. And then we have 0.075 times 30,000. That's enough. So we have 1, 2, 3, 4, then we have 15, then we have 21, 22. So move it decimal 2, 3, 4, 1, 2, 3, 4. Oh, that's 3 spaces on this one, sorry. And so that's 2250 plus 1,000. That's going to be 3250. That's what that equals. So that one checks out as well. So our values are what we found here. Okay. So again, a lot of work, nothing super hard. Everything can be done by hand as I've shown here. And so, it's just a matter of just slowly working through the problem and figuring out the answer. All right, we'll pause there and come back for more.